Okay, 5-5 notes. Students will be able to apply the SAS inequality and the SSS inequality. So before we do that, let me just show you. Let's say we have some Pac-Man here. Alright, it's like a Pac-Man mouth, right? And let's say we have a bigger opening of the Pac-Man mouth. And obviously we know that this angle here is greater than this angle here. Well, that means that this side length here, let's call it AB, is going to be less than this side length here. Let's call it CD. So we know that AB, and you know what, should have done, let's E and F. So we know that AB has to be less than CD because the angle opposite of it, angle E, is less than angle F. Okay, well, that's this theorem that we're going to learn today. Okay, theorem 513, SAS inequality hints theorem. It says that if two sides of a triangle are congruent to two sides of another triangle, that's what we had here. Here, this side and this side are congruent, and this side are congruent. And the included angle, well, included angle, that's just another way of saying the in-between angle. In one triangle has a greater measure than the included angle in the other. So here, this one has a greater measure than the in-between angle here. Then the third side of the first triangle, my first triangle being on the right, is longer than the third side of the second triangle. Bam. That's it. Let's go to the next page. Alright, the SSS inequality is simply the converse of the SAS inequality. And it says that if, and get the pen option here, if two sides of a triangle are congruent to two sides of another triangle, and the third, not thirds, and the third side in one triangle is longer than the third side in the other, then the angle between the pair of congruent sides in the first triangle is greater than the corresponding angle in the second triangle. Well, that's the same thing we just did, guys. All they're saying is, remember last time I started with the one angle being greater than the other, and now we're just starting with one side being greater than the other side, and it tells us something about the angles. So it just lets us go in the opposite direction. So take a look at this problem here. It says write an inequality using the information in the figure. They want us to compare QSR and QSP. Well, here's what we need to see. We have PS congruent to SR because they're both 12, and we have QS obviously congruent to itself. And here I have a side of 15 and a side of 14. Well, remember, 15 is greater than 14, right? Well, that means the angle that it is opposite of is going to have the same relationship. So, for example, QSR, which is this angle right here, angle QSR, has to be greater than angle QSP, because angle QSR is opposite of 15, a side length 15, and QSP is opposite a side length of 14. So their relationships are going to match up. If 15 is bigger than 14, then this angle is bigger than that angle. That's it. Well, let's plug in what that means. Remember, QSR was 46 degrees, and QSP was 5x minus 14. And I'm going to zoom in so I can have some space to do this math. Let's go over here, and I'll just do it in blue real quick. So, yeah, 46 is bigger than 5x minus 14. That's just filling in or substituting in the equation we got up here. Add 14 to both sides. Cancels out. I get 60. And then I divide both sides by 5. And I get that x is got to be less than 12. Okay. Well, check this out. Yes, x has to be less than 12, but wouldn't we have to say that this angle here, in order for this to be a triangle, this angle has to be greater than 0? So I found the upper boundary by setting it less than this angle, but isn't it safe to say that this angle has to be greater than 0? Because if it was 0, this wouldn't be a triangle anymore. This this couldn't have any length if this angle was 0. So let's do that. Let's say that 5x minus 14 has to be greater than 0. I'll add 14. Add 14. I have 14 is less than 5x. Divide by 5. Divide by 5. Okay. So now I know that x has to be greater than 14/5 and less than 12. Well, we would write that as a compound inequality. Let me do it in red so we can see it. And we'd write it as, hey, 14/5 is my lowest. Then I know x is greater than that, and x is less than 12. And that's my final answer. That's how I find the range of values for x. Okay. This next one is a proof. So get ready. Pretty exciting stuff. Okay. First up in the proof is we're going to just simply copy down all the given. So here we go. YZ is congruent to XZ. Z is the midpoint. To AC, which that tells me that these two segments here have to be equal because Z is the midpoint, but I'll put that in the proof in a second. I know that angle CZY is greater than angle AZX, and I know that BY is congruent to BX. That is all my given. Okay. And I'm going to go ahead and say that AZ is congruent to ZC, and that's simply definition of midpoint. And I'm going to also add something else in the drawing just so that I can tell. I'm going to add this thing, that angle CZY is greater than AZX. So let's zoom in. I'll add that. So I said CZY is greater, so I'm going to mark this one with 2 just to show that it's bigger than this angle here with 1. Now remember, we said if we have congruent sides, angle in between, that the side opposite the bigger angle has to be bigger than the side opposite the smaller angle. So we can say, we'll just use a different color to show this, but we could say, hey, this has to be bigger than this. Okay? And I should probably do something, I'll just do like this. So I differentiate it from these symbols here. Okay. So that's actually going to be my next statement. I'm going to say, hey, CY is greater than AX. And the reason for that is, well, this is one of the things we just learned, SAS inequality. And I'm just going to put a T for theorem. Okay. And something else I want to show you is, since we know that BX and BY are congruent, because it says so here in our given, right? Well, we can also say that, and I'll do this, change colors back to blue. I can also say that BY is equal to BX. And what lets me do that is simply the definition of congruence. Lets me switch over to equal. And I need equal because I want to do something specific to equations. So I need equality. Well, if CY is greater than AX, I should be able to add some value to either side of this and have this statement still be true. Well, I have these two values are being equal, so I could actually add BY to this side and add BX to this side, and the statement would still be true. So let's do that. CY plus BY is still greater than AX plus BX. And the property that lets me do that is simply the addition property, right? I can add to both sides. Well, I did that because look, here's CY and here's BY. And together that makes BC. And look what I'm trying to prove. BC being greater than AB. Well, look, sure enough, AX is right here, BX right here. Together that makes AB. So let's state that. I'm going to go all in red, and I'm going to say CY plus BY equals BC, and AX plus BX equals AB. And that is simply the segment addition postulate. We learned that a while back. Not ready to forget about it quite yet. Well, if BC is equal to CY plus BY, I can substitute it in for this guy here. So I can say, hey, BC substitutes in for that thing. And AX plus BX we know is equal to AB, so I can substitute in AB here, and I have BC is greater than AB, and I just use the substitution property. And that's what I was trying to prove. BC is greater than AB. Done. Okay, summary. Explain how an angle of a triangle and the size of the side opposite of that triangle are related. So you can try and explain how the angle and size of the opposite side are related. Okay, adios.